Hello, my name is Dylan Mitchell, and this is my technical presentation. So we're going to be covering UART. So what is UART? UART is a two-wire hardware communication protocol that uses two wires and a data bus to send parallel data serially between devices. Why did I choose UART? Well, UART is the most commonly used device-to-device communication protocol, and it's one of the cheapest, making it, the most used. And I also have to use UART in my group's capstone project. So what is the state of UART right now? So we kind of discussed what UART was. UART uses serial communication to send parallel data sequentially, meaning that it takes data from its data bus, transfers it in one bit at a time to a receiving device, which then reconstructs that data into its own data bus so that another device can use it. In getting into the little technicalities of it, there's a transmit wire which is held at a high voltage, and there is a start bit, which is this little zero that gets appended onto this data. When that bit gets sent over the transmit wire, it pulls it to a low voltage, which signals to this UART, this receiving UART, to start sampling that wire at the baud rate, which is predetermined by the system. And it collects all these data, all these little bits, and assembles them back into its original transmitted value. UART's one of the most common used hardware communication protocols, and going back to the current state of it, there's a lot of features that UART has that aren't commonly implemented, even though they exist to be implemented, like frame protocol, which gives more security and protection for devices communicating over UART. And down here is a frame for a frame protocol with headers, command, data lengths, and other things to ensure that the two devices talking over UART are those two devices and no other device. So the relevance to our capstone is we're using it, so we have to use it to transfer data from a host PC to our device, which is an FPGA, so that we can run our digital signal processing algorithms. We had to build an implementation of it using Verilog, which is a hardware definition language. The reason we had to do this is because not everything comes prepackaged in a way that is small and efficient to use, so we had to build our own implementation of this using our FPGA and hardware definition language. And since we're using it, and it is the main thing bringing data onto and off of our board, we have to understand it so that we can assemble that data in the correct ways, because it doesn't know the data that it sends. It just sends data at a specified baud rate, and you have to assemble that data. So if you're sending 64 bits, like a double value, you have to know, since you can only transfer up to 8 bits at a time, to assemble that 8 times so that you can put that double value into a buffer or a register or whatever you're using it. Uses for UART. So it's very useful in debugging, since you can use it to send logs back to a host device, because you can't really use a visible console on a piece of hardware. In manufacturing, it can be used like debugging to generate logs for an operator so that they can read assembly line equipment's status, and for customer updates, so somebody could use UART to put or flash new data onto a device or whatever they need to do with their own device once they buy it. And this is our roundup for the presentation. So our intro is, we have UART, which is two-wire communication, transfers parallel data sequentially, and I picked it due to its use in the capstone. The current state is it's the most popular device-to-device communication method, and it's not being fully utilized since there's things like frame protocols that aren't being used. The relevance to our project is that we have to use it to transfer data, and we've had to implement our own implementation of it, or create our own implementation. And then uses for it, we use for customers to update, to transfer logs from a hardware to a host device, and as a way to debug via logs to a host device. I appreciate listening to me. These are the sources that I used.